As part of the previous lecture, we have reviewed the details with respect to tables, orders, and odd items. In this lecture, let's understand some of the key concepts with respect to table and index. When it comes to table, we'll have multiple columns like this. You can see orders have order ID, order date, order customer ID, order status. Also, when it comes to order ID, we have a constraint which is nothing but primary key. It means we cannot have null values in order ID. Also, the values are supposed to be unique. You can see all the values are unique. When it comes to the data in tables like orders, on top of actual column values like this, we'll also have row identifiers. For each and every row or record, there will be a row or record identifier. Let me name them as like this: R1, R2, R3, R4, R5. You will not be having values like this. The values will be proprietary to the underlying database. But for now, to make it understandable, we are actually referring to these row IDs or record IDs as R1, R2, R3, R4, R5 respectively. Typically, these identifiers will be in incremental order. Incremental order means ascending order. The data will be sorted when it comes to these record or row identifiers. They will be sorted in ascending order. On tables, on some of the columns, we might have indexes. Especially if you have primary key column, there will be an index on top of the primary key column. Index can have one or more columns. In this case, we have index only on one column. It is nothing but order ID. The main characteristic of index is nothing but the data will be sorted in ascending order. You see here, the data in this column is in ascending order. It means data is sorted in ascending order. For every index on top of the column values on which the index is created, it will also have corresponding row or record identifier. That is how it will be able to relate the column values to the actual table values. For example, when it comes to order ID 1, it is part of row ID or record ID R1. Hence, there will be R1 here. When it comes to 2, it is nothing but R4. Hence, we'll be having R4 for order ID 2. In the similar manner, for order ID 3, record identifier or row identifier is nothing but R2. For order ID 4, the row ID or record ID is nothing but R3. You can see R3 in index. When it comes to order ID 5, the row ID or record ID is nothing but R5. As part of the index for order ID 5, you'll be having that row ID or record ID. It is nothing but R5. As we have understood how data is stored in index, now let's go to the advantages related to the index. The main advantage is faster search when it comes to index. For example, if you wanted to get the order details for order ID 2, you have to go through the entire table and confirm whether you have order ID 2 or not. If you have order ID 2, you should be able to fetch the details for that order ID 2. As the data is not sorted with respect to order ID, you have to go through the entire table to get the details with respect to order ID 2. It is popularly known as full table scan. It has to scan the entire table, identify the row with order ID 2 and get the value related to order ID 2. When it comes to index, if order ID is part of the index, then data will be sorted in ascending order by the values of order ID. As data is sorted, typically we will be able to search much faster. There are quite a few important algorithms which can be used to actually search the data faster from indexed column where data is sorted. I don't want to get into the details with respect to algorithms. Just keep in mind that when data is sorted, searching in sorted data is much faster. You should be able to go to order ID 2 directly and then get the row or record identifier. Using row or record identifier, you should be able to get the other details when it comes to order ID 2. Even though you have to go through both index and table, when you try to search for given order ID 2, the search will be much faster. You will be seeing much better performance when you have index versus when you do not have index. That's where the index comes into picture. It is primarily used to speed up the search on commonly used conditions. We'll go to the queries and you will understand what I'm talking about. For now, just keep in mind that table and index are nothing but data structures. As part of the table, data is not sorted and you'll be having data for all the columns. As part of the index, which is dependent on table, you'll be having only subset of columns. It can be only one column. Whatever column that is defined as part of the index, the data in that index will be sorted along with the data with respect to index column. you will also have the row or record identifiers in the table, so that in case if you wanted to access data from the table, you will be able to use this row or record identifier to go to the table and access the data. There are terms which are used when it comes to explain plans. You will understand those terms once you understand these concepts. If you don't understand these concepts, then you will not be able to understand the terms when we review the explain plans later. That's why I am actually getting into these concepts. As we have gone to the details with respect to table and index in this lecture, now let's go to the details about interpreting the explain plans. We'll also relate the terms while interpreting the explain plans with the concepts that are covered in this lecture. That way, you'll be fairly comfortable with what is going on.